Hey, welcome back to your favorite trig class. Let's finish this section up here on continuation of the inverse trig functions. So we have the sine, of the arctangent of 4/3. Let's do that in brackets there. What I'm going to do first is I'm going to go to the side. Let me go to the side for a minute, and I'm going to let the arctangent of 4/3 equal theta. Okay. And I'm going to kind of work this out and make a picture of this thing. So that means that the tangent of theta would be 4/3, where that is strictly less than pi halves. Now, if the tangent, and I'm looking between negative pi halves and pi halves, if the tangent's positive, it's positive 4/3, that means my cosine's positive, my sine's positive, my x and my y, right? So I got to be in quadrant 1. So I'm going to go ahead and draw this into quadrant 1. Okay. Remember, tangent's opposite over adjacent. And I'm going to label this opposite, adjacent right next to it. That means we're solving for that hypotenuse there. So RC. So a squared plus b squared equals c squared. I'm going to fill this out so I can answer some questions with it. Oops, 3 squared plus 4 squared, good grief, equals c squared. We got 9 plus 16, we got 25, that's c squared. So we got c is 5. So we got square root of 5 right there. Okay, so fill that out. Now, notice I went to the side and I said, I called this what? I called the arctangent of 4/3, I called it theta. And I've got a picture of theta now. So the question becomes, what's the sine of theta? Well, the sine of theta, the right triangle trig, is opposite over hypotenuse. Opposite hypotenuse. So we got 4 over root 5. So the sine of the arctangent of 4/3, which we'd call theta, right? In other words, sine of theta, is 4 over root 5. It's 4 over root, oh my gosh, you guys. Square root of 25, that's just 5, not root 5. That's just 5. Sorry about that. 4/5. There we go. Just kidding about that. All right, so we got 4/5. So the sine of the arctangent of 4/3 is 4/5. So again, number 1, write it out. Name this theta. That's the second thing. Fill out the picture. Number 3, solve for the hypotenuse there, and then answer the question. Since you know that's theta, what's the sine of theta in this case? Let's do another one. The cosine of the arc, sine of negative 1/3. Cosine the arc sine of negative 1/3. So this is cosine. I'm going to go to the side. I'm going to go to the side here, and I'm going to name this theta. Okay. So if the arc sine of negative 1/3 is theta, that means the sine of theta is negative 1/3, and this is where our theta between here and here. All right. So I'm between negative pi halves and pi halves, right? I'm looking here. If the sine, if the y value is negative, I got to be down here in quadrant 2. I'm sorry, quadrant 4. Down here in quadrant 4, so let's draw that. And the sine is opposite over hypotenuse. So opposite hypotenuse. Okay. Now I know that is a distance, but I'm going to use negative for that distance there so that my sine is correctly labeled as negative 1/3, is a negative value in quadrant 4. All right, so now we're gonna go ahead and solve for the hypotenuse. I'm sorry, the adjacent side. What am I talking about here? A squared plus b squared. I know that's just a distance of 1, but it's 3 squared. So a squared plus 1 equals 9. A squared equals 8. Square root. A equals plus minus 2 root 2. Cosine is positive here. We're going to positive 2 root 2 there. So that's the adjacent side to theta there. Now remember, we called this arc sine, we called that theta. So we go back over here and say, oh, well, I'm just solving for the cosine of theta then, now that I have a picture of it. Cosine is adjacent over hypotenuse. So the adjacent side is 2 root 2. The hypotenuse is 3. That means the cosine of theta, in other words, the cosine of the arc sine, is 2 root 2 over 3. And one more here. Good practice. Tangent or cosine, negative 1/3. Again, we go to the side here and we say, I'm going to let that composition piece inside there be theta. So that means the cosine of theta in this case is negative 1/3. And theta is between 0 and pi. Okay, so now we're looking anywhere in quadrant 1 or 2. If the cosine's negative, I gotta be in quadrant 2, right? That's where my x is. This is where my x's are negative, right? So cosine theta, draw that thing, and remember, oh heck, another hour, that's adjacent over hypotenuse. When I draw this into quadrant 2, for my theta using the reference angle theta prime, since it's right triangle trig, is adjacent over hypotenuse. Adjacent over hypotenuse. Go ahead and solve for b, the remaining side. So negative plus minus 2 root 2. So positive y there. We're going to call that 2 root 2. And we say, well, what do we call that? We call that theta. So I'm solving for tangent of theta, which is, oh heck, another hour of algebra, opposite over adjacent, or SOHCAHTOA, whatever you use to remember opposite over adjacent for the tangent. The opposite is right there, 2 root 2. The adjacent is right there, negative 1. So 2 root 2 over negative 1. So negative 2 root 2. So the tangent of the arc cosine of negative 1/3 is negative 2 root 2. Negative 2 root 2. All right, let's do one more here. I'm not going to get too worked up about writing a trig expression as an algebraic expression, but I did want to kind of introduce this to you. And so when you're working a problem like this, what you're going to do is I'm going to take that inside piece here first, and the arc cotangent of u, and I'm going to let that equal to theta, so that the cotangent of theta is u. And so what we have is the cosine of the arc cotangent of u, and again we've called this theta, right? What I'm going to do is I'm going to run a little trick on this thing. So the trick is I'm going to multiply this, because I'm trying to put this all in terms of u, and I know that the cotangent of theta is u. So how am I going to get the cotangent? Well, I need it a cosine over sine. So let me just multiply this by sine over sine. So I'm multiplying it by 1. And here's my cotangent, right? Cosine over sine there. So this becomes cosine over sine times sine. Okay, here's cotangent, which we know to be u. Okay, that's u. And what I'm going to do is I'm going to put that in terms of the cosecant. So that's 1 over cosecant of theta. And the reason is I know that's u, and I'm trying to get this other part in terms of u. 1 over cosecant. So how's that work out for us? Well, we know sine squared plus cosine squared is 1. If I divide everybody by sine squared, then 1 plus cotangent squared theta equals cosecant squared theta. In other words, the cosecant of theta is plus minus 1 plus cotangent squared theta. And we know the cotangent theta is u. So this is plus or minus 1 plus u squared. For our purposes here, we're going to assume the cosine is positive, so we're going to use the positive. So this is 1 over the positive root 1 plus u squared. So when we clean this up, we got u over square root of 1 plus u squared. Okay? Just kind of a little intro there. All right, thanks so much for listening. That's it for today. We'll see you guys next time.